So now that we've been able to look at naming of binary compounds made up of group 1, group 2, group 3 element, and then a non-metal, like the metal and a non-metal, let us look at the element or compound that is made up of the transition metals and a non-metal. And when you look at your periodic table this way, in between the metals and then the non-metal, there's a group in the middle of the periodic table. They are called the transition metals, and they have some unique properties. Now let's look at a few of them. The transition elements, we have zinc as Zn, we have lead as Pb, plumb. We did this in our previous lesson. We have iron, we have copper, we have silver is Ag, we have gold. So these are the transition elements, and some of these elements or metals are able to form ions. They are able to form multiple ions. So you have them here. Good. We can have copper existing as copper 1 or copper 2. So it can form a compound with this one or with this one. We can have iron. Iron can form a compound with this iron 2 or iron 3 and so forth. So without much ado, let's take a few examples with the ion, the transition element, and then a non-metal, transition metals, and then a non-metal. Now what happens here is not all the element, the transition metals plus non-metal. Now, not all the transition metals have 2 or more charges. Not all of them have 2 or more charges. So these are a few that we will use for now. So once you have a transition metal and a non-metal in a compound, first of all, you need to identify which ion is the transition metal using to form the compound. So let's first take, we already have our incomplete periodic table here. So let's say copper. We have copper here, and copper, and then so copper chloride, copper and then chlorine. That's copper chloride, and then we can have copper like this. So here our copper is 1 plus and copper is 2 plus. So we have 2 copper atoms. Copper, so copper here, copper chloride. Now let's work back. So Cu is plus and Cl is minus. If you look here, we already know that chloride is -1, and they actually interchange to form this. So this and this is 0. So that will give you CuCl. So this is 1. Then when you come here, we have Cu and then Cl. Now this 2 here is coming from this copper. So we have our 2 plus here, and our chloride is always minus. So like this. So when they interchange, they give us this. So here, now to name this, you maintain the same rule for binary compounds. You have to name the transition element first, and then you would state how many ions it is reacting with chlorine here. And here to state it, we use Roman numerals. So we have I, and then let's say a vein. So this is I is 1, I 2, I 3, and so forth. So if you take the first one, the copper here is +1. So here it is copper Then you bring your brackets, I chloride. Chloride. If you go to the second one, the copper here is 2. So we have copper. You bring your II2. II chloride. So let's take another example. Let's go to iron. Iron, let's say iron and then a compound like iron and then an iron and then a non-metal like oxygen. Oxygen is in group 6, so -2. So here we can have this 2+, then O2 minus. So this one we will have FeO. Then if you come to iron 3+, because iron forms 2 ions, that's 2+ and 3+. So let's do for the 3+, and then O2 minus. Now they will interchange. So we are going to get Fe2 here, then O3. Now let's look at how to name this. First of all, we know that the ion here is 2. So here you are going to get ion 2. I. Oxygen is oxide. Like this. When we come to the second one, we are getting ion. Now here is 3, because this 3 here is coming from here. So ion I oxide. I believe it's clear. We can take iron and then let's say chlorine. So Fe and then chlorine. Now let's say this is the formula FeCl, and you are asked to name this. First of all, so let's say you have FeCl2, and you are asked to name this. First of all, you have to work backwards. So you have to establish which ion is copper. So which ion is iron using to react in this one. So you go back. First, you bring your Fe here, and then your Cl. We can tell from here that this 2 here is coming from here. It's coming from, this is a 2+. We already know chloride is -1. So this one, ion here is 2+. So straight away, this is ion 2. Chloride. It could be ion 3, like this, FeCl3. FeCl3, and this is ion. The 3 here is coming from the ion. So ion I, then your chloride. I believe it's getting clearer. Then let's take another one. Let's take copper here. Let's see this Cu. That is this, and then let's take nitrogen. So let's say copper, nitrogen. Let's say, of course, we know nitrogen is 3-, and our copper could either be a plus or 2+. So if it is a plus, this formula will be, if copper is a plus here and nitrogen is 3-, this will come here and this will go here. So here our copper is Cu3n. Here you can see that this 3 is coming from here and this one is here. We don't write. So this is copper I nitride, like this. Copper into bracket I nitride. If it is copper 2, here the 2 will be here, the 2 will come here, the 2 come here, to see the copper I nitride. I believe it's getting clear. So pay attention. There are some of the transition metals that do not show variable charges. One of them is silver. Silver is Ag, and silver is Ag plus. So once you have silver and any other non-metal, you don't have to show the Roman numeral, because we know that it only has a single charge. So if it's silver and then let's say chlorine, it is like this. This is AgCl, and this is silver. I don't need to put Roman numeral to show which ion it is. Silver is reacting with chlorine because it is still one. So silver chloride. We have a couple of them. Zinc is one of them. So zinc, even though it is a transition element, a transition metal, does not exist in different forms, like different forms of iron, like the copper, the lead, and then the iron, and so forth. So take note of this, and take note that once you are naming, you will have to show the ion that the transition metal is combining with the non-metal into bracket as the Roman numeral. I believe it's been clear. Without which matter, let us continue to look at how to name polyatomic compounds or polyatomic ions with a transition metal.